I'm Jakob Nordin. I'm going to discuss the AMPEL framework for the AMPEL group. So the notebooks that I'll show are all contained in the AMPEL contrib sample repository. So if you want to further look at this later, I recommend that as a good starting point. Okay, and there are a few tutorial notebooks there. Today I'll focus on the one dealing with data exchange or interfaces. So AMPEL is a framework designed for processing real-time data. It's a little different from most of the other systems we've heard today in that it's not mainly designed as a portal for access to real-time data, but rather as a tool work to allow us to do comprehensive, complex, multi-messenger analysis on likely heterogeneous data streams. And the reason we want to create this framework where all of these aspects are integrated is that it's a path towards creating really legacy real-time surveys of the kind that that can accompany a project such as the Vera Rubin Observatory. The way we've kind of implemented this is through the idea of science schema. So these are ways to outline the contents of a scientific analysis and describe all the scientific choices to whatever accuracy is possible in one kind of in one cohesion configuration. This little figure here shows a very basic example of what this looks like, where the gray circles indicate units where scientific choices are being made. And their placement in this tree illustrates that what kind of data the choices are being made, if it's on raw input data, so some sort of filtering, or whether there are more complex choices involved. And all of them are in practice implemented as AMPEL units that can either be contributed by users or picked from the shelf from the AMPEL library. But today, yeah, I'll focus on the interfaces. Just before that, a brief comment. I think a great question for this community and looking forward to maybe 2 decades of studying of LSST real-time data is the question of, can we define a good general framework for describing a real-time analysis that is easy to understand and portable and will be useful also in the future to understand what really went down into the creation of, for example, some alert sample. So I think that's maybe a question for later. So the different levels or colors in this diagram corresponds to 4 tiers in the in AMPEL. Okay, I should also say that we do have a REST API that functions very similar to what we've seen before, and there's a link to page that describes the content. The program that we're running right now do not use them very much, simply because it tends to break provenance in that it's hard to be consistent enough in how it's being used. Okay, so internally AMPEL does processing in 4 different tiers. As can be expected, the first is all about adding data, and in the final one, you take potential reactions. So these are what's involved with interfaces. So if we look at the first layer at an abstract level, stuff is added to an AMPEL to the core AMPEL database, where it is tagged according to which channel or which channels or which users have access to it. And in principle, there's 2 steps to doing this, and both are modular and can be configured by the user. The first is to implement a controller that knows where to receive the data from. So we have, this is an example from the CTF alert stream controller. I'm not going to go through all the details, but as you can expect, it's hidden a Kafka client in there. But the principle is similar for whatever information you want to have, and you just heard the schema presentation, and it's of course straightforward to extend it to that, where you then can, for example, listen to your own streams from that source. The second step is an ingester. This is simply a process that knows what information from the stream you want to have access to later, and whether you want to do some sort of conversion. Typically, for example, you might want to store magnitudes and coordinates in a quiescent fashion. So once these units are defined, they are collected in a configuration file that belongs to each channel program or experiment. And here's just a very short cutout from one such sample, minimal configuration file. Under your controller, you request one or more stream controllers that will then put data into your project. Each of them as directives have some sort of a content ingester that then adds information to your data set. Once there, it can be processed by your program. I think in one of the sessions tomorrow or Thursday, I'll describe that more. Then I'll move to the final tier. So this is the reaction layer. And this is a tier where a user or a channel gets access to all their transients that have been active lately, and then decides to take some action based on those. And that's in general carried out with what we call T3 units. So this is a class that's being called on schedule or where you want to have it done, and gets a list of candidates. And it's a question how you want to react to them. And it's a layer that's very often implemented by the different experiments we're hosting, in the sense that this is typically where you do very experiment dependent cuts. For example, what sort of light curve criteria do you accept as reasonable, and so on. And there are, of course, also predefined such that you can have. We've seen similar to the LCO Aeon Tom Toolkit reactions. That would be typical T3 units or sending alerts. Or this is something we also mentioned, sending some candidates for visualization in some, for example, the Sky Portal instance. It's just some sample documentation about this. This is then a unit that's similar to before. In your configuration file, you simply request this to be run, and then you will have your candidates posted into a Sky Portal instance of your liking for visualization. So this was a very abstract overview of interactions between AMPEL and the outer world. I recommend you to look at these notebooks to get a more practical idea of what this means. In general, the way we operate is that a channel or an experiment is first developed locally based on some set of training or fixed training data. Then it can be run on archive data. And then finally, it's uploaded into a live AMPEL instance that then tags into whatever live streams are requested. And I think I will stop there for today and take any questions.
Thank you, Jakob. Any question? I also don't see any question in Slack.
I have one question, very quick.
Yes.
So, Jakob, I see that the repository you showed at the very beginning acts as a template. Do you recommend it to start building a pipeline with AMPEL?
You can. It is a, sorry, let me. And this is so it contains tutorial notebooks and also even some sample data. So the way that people start using this is that you run the tutorial notebooks and then you modify them to get it similar, to get it matching some analysis that you want, that you're interested in. And then you clone this to AMPEL, contrib, whatever identifier you want to have. And then since it's running in this development environment, it's already ensured that it will also run on a live AMPEL instance. Of course, eventually you don't want to run it on locally on a machine. So then you will want to run it on some computer center where you have access to catalog matching. But in principle, you clone this and start developing your own AMPEL units.
Okay, thank you.